Hello everyone. Today we are going to teach you on how to easily derive Black-Scholes-Merton model, a legendary equation which has transformed the world of mathematical finance. Some of you may think that this is difficult, but after watching this video, you will learn that it's easy, simple, and understandable. What is Black-Scholes equations? It's a partial differential equation developed by three genius economists: Fisher-Black, Myron Scholes, and Robert Merton. This equation is used to price European call or put option on an underlying stock paying no dividends. As you can see from this equation, V is the price of the option as a function of time and stock price. However, BSM equations has some underlying assumptions. First, stock price follows stochastic process, meaning that we cannot use historical price to predict its future movement. Second, there are no dividends and transaction costs. And third, risk-free rate and volatility of stock price is known and constant. Next, before we can derive the equation, we have to understand major components behind the model. First, geometric Brownian motion. Second, Ito's lemma. And last, delta H portfolio. First, geometric Brownian motion. Initially, there's generalized Wiener process called arithmetic Brownian motion, which shows changes in stock price that comes from two terms. First, drift term, which represents the expected return of the stock given very small change in time. Second, variance term, which represents volatility in stock price given DC, which comes from this formula. However, this arithmetic Brownian motion violates two realities. As you can see from the graph, the linear growth stock price doesn't include compounding effects, and the stock price can be negative, which cannot be true in real world. So we employ geometric Brownian motion to solve this problem. By adding S into each term, the equation comprehensively accounts for compounding effect and also has absorbing barriers, which means that if S becomes zero due to company's bankruptcy, there will be no further change in S at all. Let's move to the next major component, Ito's lemma. The equation here represents the change in value of an option as a function of stock price and time. And now, our last component is the delta H portfolio, consisting of two terms, a long position in call and a short position in stocks. And now, we are ready to derive the Black-Scholes-Merton model.
First, let's start with our geometric Brownian motion or GBM with the following equation. Then we want to square the equation, which will result in this following equation. And then we want to try to eliminate some terms of this equation. We see that as dt itself is very small, dt squared is approximately equal to 0. And then for these z squared, we see that it's approximately equal to dt. And then for dt times dc, we see that it's approximately equal to dt to the power of 3 2, which is very small, approximately to 0. Therefore, we can eliminate this one term and this one term, resulting in only one term, which is sigma squared, s squared, and dt. Next, let's come to our Ito's lemma or dv with the following equation. Then we want to try to eliminate some terms. We see that as dt squared is very small, approximately equal to 0, we can eliminate this term. Then we want to determine the dt multiplied with the s. We see that we can expand this into dt times the whole bracket of mu s dt plus sigma s dz. Then we multiply dt into each term to get mu s dt square plus sigma s dz dt. And then we know that dt squared is approximately equal to 0. And we know that dz times dt is equal to dt to the power of 32, which is approximately equal to 0. Therefore, this term is equal to 0. And then we eliminate this term. So we come up with the last three terms. And then we will substitute GBM or geometric Brownian motion equation into this ds square to come up with the resulted dv. Now, let's come to our delta hedge portfolio with the following equation. Since we want to know the change in value of portfolio, we change the equation a little bit into d pi equals to dv minus delta ds. And then we substitute Ito's lemma into dv. Then we want delta to be equal to dv ds in order for these two terms to cancel out. So we have only three terms left. And then we know that d pi is also equal to r pi dt. And this r pi dt is also equal to r times the whole bracket of v minus delta s dt. Then we eliminate dt of this equation. And then to come up with the following equation. And then we do the algebra to move all the terms into one side. And here we are, the equation of Black-Scholes-Merton model.